marks, one particular subject weightage is of 10 marks. Another subject weightage is of 12 marks. One more subject with nearly 10 subjects, approximately 10 subjects are there. You just verify. One particular subject weightage may be 2 to 3 marks only. Don't neglect but priority. Okay. Suppose one particular subject weightage is 15 marks, it is giving in the sense. Okay, 15, 12 and 10. If you add, suppose just 3 subjects only. 15, 12 and 10. If you add, how much total? 37 or not? You are all CSC students, I think so, means computer science related students. On an average, means approximate qualifying marks in GATE exam for computer science related subjects, it is for 25 to 30 only. Means if you are able to score more than 25 marks, approximately on around 30 marks, you will be qualified in GATE examination. So if you score more than 50 marks, 100% you will get a seat in IITs. You can get a seat in IITs definitely. If you score more than 50, 55 to 60 is a 100% sure case. 45 to 50 or 55 range, you can get a seat in NITs. That too good NITs, reputed NITs, you can get a seat. So scoring, if you prepare strategically, scoring 45 to 50 up to 60 is not a big task. So previous GATE questions, prepare previous GATE questions, okay, and last 5 years GATE questions, and write more number of test series you write, definitely you can crack GATE examination. If you see, if you have a strong desire, better you start now only. From second year onwards, that is a better idea to prepare GATE examination, not in third or fourth year. Start now only if you have a strong desire. Okay. Now, okay, without now coming to even mathematics also, mathematics and discrete mathematics together, both subjects together, 20 marks in GATE. Okay, 20. Mathematics and discrete mathematics is one of the subject. I think in 2-1, is it? Now it is discrete mathematics is going on. Okay, so for some of you, some of the branches. So maths and discrete maths together 20 marks. Aptitude itself is 15 marks. Means if you prepare these 3 subjects, definitely you will be qualified in GATE exam. Definitely you can. Okay, so this type of strategic preparation required. Now coming to probability and statistics. Today and tomorrow completely we will discuss probability and statistics topic along with some previous GATE questions. I will give you the complete view and idea. Probability and statistics, it is very important for computer science student. Computer science, data science, machine learning, artificial intelligence, not only for GATE or ESC, I am not telling about just competitive examinations. Even in real world practical life also, particularly you are going to become a software engineer mostly. All applications are related to probability. Most of the, even machine learning, some of you are ML students. Is it? Complete machine learning applications are related to linear algebra and probability. Data science applications are completely related to probability and statistics. So prepare thoroughly. Thoroughly you prepare. Not for exam, not for the sake of exam only. Is it? Definitely. Not only any competitive exam you can crack, not only competitive exam. Even suppose if you go to industry also, there also you can create wonders. If you have a strong idea on mathematical skills. Okay. Now, pen any pen, okay. Generally, probability and statistics, this subject actually in now it is a present running subject to you, is it? But the word probability, you know, in 10th standard only, even in intermediate also probability subject is there. Most of the students are afraid of probability. Some of the students are confusing in probability, but only some students felt it is easy. But I have a small doubt. రివర్స్లో రాయాలా? See, generally, to solve the probability problems, most of the students you have a doubt, some basic confusions in permutations and combinations. I will not give you complete permutations and combinations. That is a complete, that is completely one topic in discrete mathematics subject. Briefly, what is required for probability? Okay, how see? Some areas of permutations and combinations required to solve probability problems. What are required to me? That part of permutations only I will give you. Okay? Not elaborately, briefly. Okay? Generally, in permutation, what is the meaning of permutation? Permutation, say, just you listen the class. After maybe at the end of the class, my classroom running notes. Okay? My classroom running notes also I will share at the end. Okay. What is the meaning of permutation according to your knowledge? You tell me. Permutation means already you know in 10th standard only you know this word. Even in intermediate also most of you have prepared for MSET, IIT, JEE, permutations, combinations, probability topic. Tell me what is permutation according to your knowledge? Permutation means simply arrangement of objects. Permutation is nothing but arrangement of objects. Very simple words. I will not use very big words. Simply permutation is nothing but arrangement of objects. An arrangement of objects, right? Okay. Arrangement of objects means we have a doubt. Generally, we can arrange the objects with repetitions and we can arrange the objects without repetition also. Generally, in permutations, in earlier classes, you have followed some formulas. What are those formulas? That is NPR. Is it? And for some means some problems you have solved using this formula NPR. Some problems you have solved with n power r. Is it? For some problems you have applied this formula NCR. Is it? For some problems you have solved like this, maybe NCR plus NCS, sum rule. We call it as a sum rule. For some problems you have applied like this, NCR into NCS. This is product rule. Is it? Generally, these are the major doubts and confusions for most of the students. When NPR, when n raised to r. When NPR, when n power r. When NCR. When sum rule, when product rule. These are the major doubts even in discrete mathematics subject also. With very, very simple examples, I will try to clarify. I will not give you formulas. Don't follow formulas. You just follow the concept and logic only. You are, see, you are preparing by using formulas means confusion starts. Is it? Only through concept you have to. Now coming to, I will explain with simple observations, with simple examples. I will try to solve the questions logically. I am not giving theory first. Say this. Permutations without repetitions. Okay, sir. Okay. Now coming to, generally we can arrange the objects in two different ways. After completion of today's class, my running notes I will share to group, and you can say permutations, but you write it parallelly. Permutations without arrangement, without repetitions means generally we can arrange the objects in two different ways. One is without repetition, second one is with repetition. Generally without repetition, one formula, with no formulas. And complete topic will discuss logically, will try to avoid formulas at most. Is it? Yes. For example, directly I will start the example. Generally, every theoretical development given from the practical view only. Is it right or not? But reverse order we are following. We are following the book, using the book, what is there you are writing now. No. The theory actually what it say. You are observing some theory in book in sense, how it comes from the practical view or geometrical view only that theory was developed. Is it? So directly we'll discuss that practical view. For example, I will give you one very simple question. Try to solve this logically. In how many ways? Very simple question. In how many ways four children can sit in six chairs in a row randomly? This is my question. This is my question. Okay, I will share it. You just explain. Generally, it will be uploaded parallelly. Okay, you just tell me the answer. Answer means don't want to give the answer. Just you think about that logic. Say this. How many children are there? Four children. How many chairs are available? Means six slots are there. Within those six slots, I have to arrange four children. Is it right or not? Yes. To sit a first child solution, I don't want to give any formula. You say this. For the first child, how many chairs are available? How many chairs are available? Six chairs are available. Means first child can sit in any of the six chairs in six ways, are there or not? There are six ways to sit a first child. Is it right or not? Yes, six ways. Clear? And why? And generally we are continuing the task. Generally you are all computer science students. Where AND gate applies and where AND gate applies? Continuation of the task. Is it right or not? AND operation means task not yet completed. And generally in English language, okay, complete the digital logic, Boolean gates, all are applicable. See, generally in English language, arrangement of first child, and arrangement of second child, and arrangement of third, and arrangement of fourth, like that only we are using or not? Here AND gates act. AND gate means is it product operation or not? Yes, obviously. So six ways. For the second child, already first child occupied one chair in sense. For the second one, how many chairs left? So he can sit in five ways. Is it? For the third one, Andy, four chairs are available four ways. For the fourth child, Andy, three ways. Total, how many children are there? Four children. Completed or not? What is my final answer? You tell me. 6 into 5 into, because product operation task we have continued. 6 into 5 into 4 into 3. And that itself is an answer. Why formula? No formula required. If you want to make it as a formula for a textbook format, say this. What I did here, I have written 6 4 times back or not? 6 into 5 into 4 into 3. So notation, I want to give a notation 6P4. 6P4 means, meaning P means a permutation. 6 slots are available. Among 6 slots, I used how many slots? We can use any 4 slots out of 6 slots in 6P4 ways. Just it is a notation only. Now tell me what is 6P4 answer? 6 into 5 into 4 into 3. Actually, you have followed NPR formula. NPR is nothing but n factorial by. Leave that formula, remove him. No formula required. That formula comes from this logic only. Is it? So, from this observation, suppose in a 7p2, what is answer for 7p2? Just 7 into 6. Why formula andi? No NPR formula. Is it? Tell me what is 8p3? That's it. Is it? So it is looking like, this observation is looking like NPR formula or not? One undercurrent observation, that is 4 children. See here, first for the first child 6 chairs are available. For second one 5. Means repetition of chair not allowed here. Why? Because already one child occupied one chair in the sense, yes, the chair will not come for the second arrangement. Already 2 chairs are occupied in sense it will not come for the third arrangement. Is it right or not? So here one undercurrent observation, repetition of chair not allowed. Okay, without repetition or with repetition it is? Without repetition. But that in the question I did not give that word. Is it? So try to solve logically. I will give one more example for more clarity. Where is remote? ఇలాగే అమ్మా హ్యాండ్తోనేనా మూవ్ అయిపోతుందా? అవుతుంది. దిస్ వన్ కమ్ హియర్. ఇక్కడ మూవా? ఓ ప్రతిసారి ఇలా అంటే ఇట్లా అంటారా మీరు అనేది? సైడ్కి సౌదా? ఓకే 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 బెటర్ మూవ్. ఓకే అదే బెటర్లేమ్మా, మూవ్ చేయి, పైకే మూవ్ చేయి. ఇంకా ఇలా మూవ్ చేసుకుంటావేనా? ఓకే ఓకే, దట్స్ ఓకే. Right. I will give one more example for more clarity. Say this. In how many ways 3 books can be distributed to? Three books can be distributed to 5 students so that no student can take. See, my session is actually I am taking a class on smartboard. Some important key points you write. Okay, complete notes they are going to upload, and already I told you my running notes also I will share later. Okay, not now. Can take more than one book. Again logically you try to solve this question. I don't want to give any formula. I don't know formula also. Leave it. Logically you try. Just with logic. Amma? How it is 5p3? That is okay. See what you are telling 5p3, you are giving that answer using logic or using formula? Don't use formula, just what? Again logically, amma. Think carefully, think. Again here also solution. See, this doubt also very important here. Sometimes English language also plays an important role here. You are distributing books to the student. Books, you are giving books to the student. You are not giving student to the book. Is it right or not? What you are distributing? Book you are distributing to the student. Is it right or not? Yes. To give a first book, books we are giving to student. Is it? This is very important. To give a first book, how many students are available? 5 students. It can be done in how many ways? 5 ways. Understood? And task not yet completed. So that under operation. To give a second book, why 4 and condition given here. Read that sentence carefully. No student can take more than one book. Means here already one student has taken a book. The student is not allowed to take the second book. So for the second book, four students left. Four ways. Clear or not? Sorry, four ways. For the third book, B3, three ways. Now what is my final answer? 5 into 4 into 3. Notation wise, that is nothing but 5p3. Just a notation only, you just use it as a notation. Why notation means sometimes using notations also they are asking the questions just for the sake of exam purpose. Okay, right. Now from these two examples, see previous example and this example. From these two examples, say this. Both the examples gives without repetition case only. In first example also no chair repeated. In second example also no student is repeated. From these two examples, what is our observation? If I arrange objects without repetition, generally it look like NPR. So from this, blindly you can fix in your mind, NPR formula is strictly meant for arrangement of objects without repetition. Now I will write the formula. Completely we are going in reverse order. Don't confuse. Actual rule is I have to give formula first. Using the formula we are solving the problem. But we are doing in reverse manner. Complete topic will go accordingly. Is it? Yes. Now formula, coming to the formula. Here I will write the formula. What is that formula? Number of ways of arrangement of R objects out of N objects without repetition. NPR. Is it? Just. Hmm. What is NPR? I don't want to write any formula. What it is? For 5p3, I have written 5 three times back or not? Like that NPR, what I have to do? N into N minus 1 into N minus 2 up to R times. Up to R times you have to write back. In earlier classes, now in every book you can observe it as a formula n factorial by n minus r factorial. Just for the namesake only, for protocol purpose only, I am giving it as a formula. Clear? This is a reason why we are using NPR, where it requires, very important. Now coming to NPR related, I mean that without repetitions related, there is one probability question. There is one probability question, but still probability not yet given to you. Just half of the question without using the word probability, with the permutations logic only I will write that question. You tell me the answer, try to answer that question again. Emma? Okay, right. Right. Now I will write one problem. You try now. Oh, okay. Just I will write the problem only. ఆ టైంలో ప్రాబ్లం రాస్తారు. మీరు క్లాస్ విన్నోళ్ళు ట్రై చేయండి అమ్మా. You just no need to write that question. Already you will upload. That will upload. Don't worry. You see that question and try to answer it. Okay? Say, 4 boys and 4 girls are sitting in a row at random. Total 8 persons are there. What is the first question? In how many ways? Say, some seats are there in front bench. Better you come here and sit here. Say this. Total it was 3 questions given from the same data. What is my first question? In how many ways we can arrange them? See, first question is a plain question without giving any condition. Total how many persons are there? 8%. In how many ways we can arrange them means we have to arrange all the 8% or not? See, we are arranging all the 8% means total, say, in previous 2 examples, out of 6 we have arranged 4. Means 6 we have written 4 times back. In second example, out of 5 we have distributed 3. 5 we have written 3 times back. But here total 8% are there. All 8% we are arranging. Is it right or not? All 8% we are arranging means what it is? I have to write 8 times back or not? My first question answer is 8 into 7 into 6 into 5 into 4, 3, 2, 1. It is nothing but I have written 8 times back or not? Is it factorial or not? From this one new observation. When factorial comes, okay, sometimes 4 factorial, 5 factorial, 10 factorial you are writing or not? When factorial comes, if I want to arrange all the available objects, if I want to arrange all the available objects without repetition, if I want to arrange all n objects without repetition, then only factorial will come. Otherwise, factorial will not come. Because here we are arranging all 8%. Okay, kept in mind. Now coming to answer my second question. What is second question? We can arrange so that all girls must sit together. Condition given and first question no condition given means direct 8 factorial, but second question with condition we have to answer that question. All girls must sit together means condition given for boys or girls? This is very important. Condition not given for boys. So boy 1, boy 2, boy 3, boy 4. Don't confuse here. Boy 1, boy 2, boy 3, boy 4 means this is not the order. These are boys slots. 4 boys slots are there. Within these 4 slots, B4 may come to first place also. B1 may go to third place also. B3 may, all possible arrangements you have to give or not. Don't think these are the boys. These are the slots of boys. There are 4 slots for 4 boys. Is it? Yes. Now, girls also there. But condition, what is the condition? All girls must sit together. Since they are sitting together at one place, either it is whether it is a boy or a girl or pen or pencil, living or non-living object, whenever together comes, first you consider them as a single object, single girl. All since all 5 girls are sitting together at one place, consider them as a single girl first. 5 or 4? 4? Okay, 4 galls. See, G1, G2, G3, G4. Total 4 galls. You consider them as now. Total how many slots are there? 4 plus 1, 5 slots. Total 5 persons. 5 slots are there, 5 persons are there. Like the previous question, 8 slots are there, 8 persons are there. We can arrange them in 8 factorial ways or not? Here, total 5 slots are there. Within these 5 slots, we can arrange 5 persons in how many ways? Total 5 slots. Don't leave that number 8, amma. Total 5 persons are there because these 4 galls as a single gall. Total 5 persons are there, 5 slots are there. So, within these 5 slots, 5 persons we can arrange themselves in how many ways? 5 factorial ways. Is it 5 factorial ways or not? How that 5 factorial? G may come to first place, B1 may go to fourth place, B4 may come to first place, B2 may go to fifth place. Like that different, all possible shufflings. How many? 5 factorial. Answer not yet completed. Why? Even these 4 galls are sitting together, even it may be in fifth place or in first place or in second place, since these 4 galls are sitting together at, and even they are sitting together at one place, suppose U4. Within this place itself, these 4 galls can shuffle themselves again or not? In how many ways they can arrange themselves separately? 4 factorial. So, arrangement of all these persons in 5 factorial and means into. Arrangement of these 4 persons in 4 factorial. This is a perfect logic for this question. But this question they asked in probability. If it is a probability, how they will ask, how to answer, there I will give you later. Now coming to answer the third one, and boys and girls sit alternately given. Boys and girls sit alternately means, say this like this: B1, G1, B2, G2, B3, G3, B4, G4. Is it an alternate arrangement or not? Wait, here there is a small observation. These are 4 boys slots. Within these 4 slots, is it? Within these 4 slots, these 4 boys, they can arrange themselves separately or not? B4 may come to B1 place, B2 may come to B4 place, B3 may go to B4 place, like that. Within those 4 slots, 4 boys can be arranged themselves in how many ways? 4 fatal ways. And task not yet completed because I have to arrange girls also or not. Similarly, within these 4 slots, 4 girls can be arranged themselves in how many ways? 4 fatal ways. Is it a final answer? Is it a final answer? Why no? Some of you said no, sir. What you said? Yes, sir. What you said, it is right. Why? Why it is not a final answer? 100%. Those are all possible ways are there, clear? Is it a final answer or not? No. Why? The question is, we can arrange boys and girls alternately given. But with whom I have to start? That is a doubt. If I start with the boy, these are all possible answers. I can start with the girl also. So, if I start with the boy, these are all possible answers. Or, first time I am using OR operation, you say this. Here, OR gate acts here. That's it. First time I am using OR operation. So, you can start with the girl also. G1, B1. G2, B2. G3, B3. G4, B4. That's it. Here also same logic is applicable or not? Here also 4 fatal into 4 fatal. Now what is the final answer? Therefore, final answer is nothing but either this or this, means all possible answers I have to write or not? All possible answer means I have to take plus operation or not? So from this one blind observation, and means product, or means plus. Is it? And means product, or means plus. So what is my final answer? 4 factorial into 4 factorial plus 4 factorial into 4 factorial. That is nothing but 2 into 4 factorial into 4 factorial is an answer. Clear? Like this, complete NPR, all these are related to permutations without repetitions model only. Why I am stressing these points means in probability these are very important observations. You can avoid confusions in probability problems later. Now coming to permutations with repetitions. Without repetitions enough. We are not teaching this area what it is. Permutations for probability what are required for me, that part only I am giving. Once again I am telling you, permutations with repetitions. Here also generally with repetitions we are using n power r formula. Again don't use any formula. I will give one question and try to solve this question logically. Here also directly I will go to the question. In how many ways? Some books distribution problem given to you earlier. Same problem I will give with a small change. In how many ways? What is that question you tell me? 4 books are, whatever it may be. 3 books can be distributed to 5 students. Same question, but what is the difference there and here? There, no student can take more than one book, one condition given clearly, but here that condition I removed. So, if I remove that condition, what is the solution structure changes? Where it is, for the first book, to give first book, how many students are there? 5. To give the second book, how many students are there? Again 5. Why? No student can take more than one book is a previous condition. Here such condition is missing me. Suppose a student has taken one book, in sense he is allowed to take the second book also, because the condition not given. Randomly you can distribute. All 3 books you can give to 5 single student also, no problem. To give a again 5. Even for third one 5. Finally what it is? 5 into 5 into 5. 5 cube is an answer. Is it looking like n power r formula or not? I will give one more question. Actually, that is a probability question. Once again, right, like this. One more question. Here, try to solve this logically. This question. In how many ways 4 persons can celebrate their birthday in any month of the year? No formula, without using any formula, just with logic only. See, again, logical answer. For the first person, how many months are available? Any month of the year. First person birthday can fall in any month out of 12 months. Is it? So, for the first person, how many months are available? 12 months are available. 12. For, and because task we are continuing, birthday of say number of ways for the first person and for the second person and for the third person, like that only. For the second personality Again 12. Why? Because birth month may be same. Suppose your birthday falls on January, maybe her birthday also falls on same month also, is it? So this month may be repeated. Here also 12. Here also P3, 12. Here also 12. Is it? 4 persons. What is the final answer? 12 into 12 into 12 into 12. It is looking like 12 power 4 or not? In both the examples, one common observation, both are related to repeated models. Arrangements, we have taken the repetition or not? Means both are looking like n power r or not? So from this, n power r formula is strictly meant for arrangement of objects with repetition. Arrangement of objects with repetition. Just for the namesake, I will write the formula again. What is formula? Number of ways of arrangement of R objects out of n objects with unlimited repetitions. N power R. But you leave it. Just in every book you can observe that formula. That's why I am giving it as a formula. But no formula. All of you listen carefully. Ask your doubts in break time also. Feel free and you can ask me. But don't discuss with each other. So creating noise itself is is it? So when NPR, when n power r, enough. This means for probability, these models are sufficient for me. In permutations elaborately, but we are not discussing that topic. It is not a part of probability. Leave it. Now coming to when NCR. See, parallelly, along with NPR and n raised to r, I have given sum rule and product rule also. When addition, when multiplication. This is also very important in probability problem. Next, NCR we are using sometimes. When NCR, C means combination, P means permutation. What is combination? Combination is a selection of objects. What is the difference between permutation and combination? This is very important observation. Here I will give that clarity. Combination means simply selection. Suppose see, three objects are there here. Suppose you see, two bottles along with this, suppose this one. Three objects are there. In how many ways we can select? Just I am selecting. We are not arranging. Is it right or not? Just I am selecting the objects here. We are not arranging. But arrangement means first I have to select and these selected objects also I have to arrange. Is it right or not? In selection, no arrangement is, say, arrangement not required. But in arrangement, first selection and then arrangement. This is very important observation. Generally, without using formulas here also, I will explain. See one problem, I think very means half an hour back, one problem in the beginning. I started my lecture with that example, one small example. What is that example? 1 minute. First question, what it is? From that I will explain. Without repetition, where it is? This one before, say this. Say this, carefully say this problem. In how many ways 4 children can sit in 6 chairs in a row at random? This is our logical answer. What it is 100% right. My final answer is 6 into 5 into 4 into 3 is 100% correct. But you see, in most of the books, the solution structure is not like this. If you observe, if you verify this question, in this type of question, in most of the books, the solution structure is not like this. They will follow one rule and regulation. They will follow one rule. What is that rule? Now here I will give that clarity. For this question, again I will rewrite this question. Okay? From this I will give that observation. This point, listen carefully, listen. It is very useful even in discrete mathematics topic also. See, here I will write. Combinations. What is combination? Combination is a selection of objects. Simple, with simple words I will write. Just simple line, enough. Combination is a selection of objects. I will explain with an example. Example means already known example I am taking, means already given. What is that question you tell me? In how many ways? In how many ways 4 children can sit in 6 chairs? Can sit in 6 chairs in a row at random. Randomly, how can? Yes, this is my question. Already for this question solution completed. What it is? 6 into 5 into 4 into 3. Answer? We have taken a notation as 6p4. Clear? From this observation, this observation you can observe in most of the books as a solution. Our observation is simple.